All right. This is the okay. I don't know which button I'm clicking. Right. So we are here once again. Let me just pop out the chat. This should work out. So where are we? We are previously looking at the MedSat code. Yep, things are making sense right now. And quick sort. We are going to recursively call the function. Obviously, so in the partition function, you store the pivot and you store the local wall. The the element to swap at the partition. I mean, the element smaller than the pivot element will be placed on the left side, and they will be placed at the right side, and finally you update the pivot. That's it. Good. And now, what are you doing? You are calling the main quicksort function. Again, it takes the array, takes the low, it takes the high, and this is if condition can be a loop as well if you use recursion. So the partition is returning the partition index. So you get the partition, and you do the partition for the before part, and you do that for the after part. That's good. That's it's just good. So since we are manipulating the array itself, because it is internal sorting, let's see, is quick sort internal sorting. So breaks are necessary between hours. I see that as a case. Mhm. Yes, quicksort is an internal sorting algorithm. That is good to know. So we will be coding until 11 and I will take a break for 15 minutes and we will do another session because it is reducing the efficiency if you do more than an hour. So breaks are necessary. So I studying. And this is a partition function. And this is a quicksort function. So again you will have an array. And you will have a low, you will have a high. This is very small code. P is equals to partition. Yeah, it's actually int p partition. The spelling's messed up. Partition. What are you partitioning? The array and low and high. Initial partition. And you will if okay, as I told, this should be a recursive function. So you will partition until the low is less than high. Okay, because this is a recursive function, you can write it over here as well. Yeah, I got this one right. Come on, mate. Oh, nice, nice. Partition it and call the quicksort. So what are you calling that? You are calling on the array and row and p minus 1. And you are calling the quicksort on the array, you will start from P, comma high, or that is it, right? Yes, sir. So, okay, partition element is placed over there. Why partitioning it again? I mean, this won't cause any error, but it is just not required. P is good to go. Cold. That's it. Call stuff in main. So, let's get to what? No, what's happening? Yeah. So, wow, we learned quicksort. I didn't believe that. So, two functions and one main function. That's it. No, actually, partition. Int array, int low, int high. You are supplying things here. And what are you going to do with the partition now? You will have two constants. You will have pivot. Pivot is equals to I. There is actually a name for this one. And I, that is going to be the tracker or the wall, low minus 1. And what are we going to do? You are going to iterate. Iterate through that. Less than, what is the size of the, okay. You need to iterate until the pivot. No, you don't need to iterate through the pivot. You need to iterate before the high, because some elements I don't think it matters, because pivot is equals to high, right? This statement gets executed before whatever. Technically, no, because high value is from here and it will right from there. Because you are thinking in recursion, right? Or the high value gets changed every time. Okay. See, these are the confusions that you are going to get. Obviously, it is pivot here. Okay, I completely messed up. And I say the full one, right? Okay, congratulations. Thank you. Okay, this line of code has started our imagination to recursion. J is equals to low, j less than high. You are iterating through that, and if the element is less than or equal to the pivot, what are we doing? We are initially increasing the bounds, and then we are swapping the things. And what are we swapping? What are we swapping? We are swapping RFJ, obviously, with load array of j and I. Are we swapping them? Yes, J is the found element. Yes, sir. So after the end, you will just swap the pivot with the what? Array of I plus 1. That's it, right? This is a pivot function, if I'm not wrong. And sorry, the partition function. Yeah, what are we doing? We're doing quicksort now. And it takes an array, it takes a low, and it takes a high. So you're doing this as long as the low is less than high, and you are recursively calling stuff. So first you need to get the p. What is the value of p? Yeah, call the partition. This function called, so don't give the parenthesis. Oh, you don't know. Just call the partition function and store the index. And quicksort array. Quicksort's correct, right? Okay. And so from low to p minus 1, you are going to quicksort it. Why is it not showing? Alright, I don't know. Okay, p plus 1. This recursive function looks good. Void main int array is equals to let's give it array 4, 3, 6, 7, 9, 10, 5, 45, whatever. And int size is equals to size of array by size of array of 0. Int low is equals to 0, high is equals to size minus 1. So call the quicksort. Why is it not showing quicksort net? Array low high. I don't know. Expect, what do you expect? Okay, extra one. A deep stack overflow. Very good. License and smell mistakes. Yes, definitely smell mistakes. Hmm. Okay, partition's not returning. So you read the mistakes. So the pivot is not the index, but the element. Absolutely. Absolutely. Pivot is element but not the index. I'm an engineer. Okay, we got any chat. Yeah, I do not have any other option, man. చేయాల్సిందే. So, okay. Okay. This thing is entirely wrong. Swap the current pivot with the correct position. So array of I and array of I plus 1. Okay. And return what? Return the index. Now is this thing working? It is size, not n. Okay, thank you, man. Thank you, thank you, thank you. Wow. So what is that? Where are we saving it? This is the one. Okay, this is the original code. This is our code. Okay. Whatever, as ugly as it might seem, it is good. Okay. Finally, it is done. Major milestone in mastering algorithms. No, not heaps out. Priority, yeah. Yeah, what is next in here? We completed this. The fourth one's mid sort. Okay, dude. Much easier than quicksand. Okay, clean and predictable. Ouch, it's well, no one's watching. Hello. Is there any way you can edit it in the shots? Yeah, we will see that later. Okay, you are given it an array. Now divide it under size becomes 1. Conquer it. Then merge it. Ouch. Okay, merge. You need low, you need mid, you need high. I is equal to low, j is equal to mid plus 1. K is equals to 0. Temporary array. Okay. So you took array, you took low, you took mid, you took high. I is a pointer to low. Okay. Do we have two functions here, merge and merge sort? Yeah, partition and quick sort, merge and merge sort. Let it be. Okay, we are calculating the mid. Low mid plus 1 high. Okay, sort them and merge them. Nice. 0 and 5. And the full array. Okay, we split it. I is a pointer to the left sorted half. J is the pointer to the right sorted half. Okay. 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 Index of the temporary array. Okay. You need to buffer the temporary. Restore the sorted result. So is it external sorting? Oh, I got this question. Okay. Two pointer technique. If left has a smaller element, move to temp. Mid and high, so that's the right sub half. Two pointer. There is no easier path. I'm really feeling sleepy and I'm all alone over here. I guess I gotta push it. There is no other way. So merge. Okay, 2 pointer. Two pointer. Alright. Oh, now that I have noticed, I haven't started talking. Oh, maybe. I guess I'm in the understanding phase. Wow, this is beautiful. This is beautiful. Okay. Okay. Can you draw a line? What's happening? Yeah. That seems good as it is. So merge sort, it contains two functions as we have seen. It contains a merge function and it contains a merge sort function. What is the merge function doing? So void merge. Actually need to take the array low, mid, high. So this is first array and this is second array. What are we doing initially? Are we initializing the indices? Yeah. Int I is equals to low, j is equals to mid, k is equals to 0. Pointer to first and second subarrays. K is equals to buffer and int you are storing a temp. What is damn temporary of 100 buffer? Okay. So what are you doing initially? You need to use two pointer logic. You need to traverse, right? Yeah, I know why logic is gonna come over there. All right, let's visualize it. An array. This is low. This is mid. This is high. So this is one subarray. This is another subarray. So low is less than or equal to mid. Mid is less than or equal to high. Okay, two pointer. Two pointer sort in buffer. Sort the remaining. And the remaining elements. Right, let's say So does the order matter? Yes, the order matters because you are dealing with sorted subarrays. Did you implement Quicksort this hour or the previous hour? I implemented it this hour only, right? Okay. If I did implement it, then it's good. If I did not implement it, then that's not good. So, what now? Okay, while I is less than or equals to mid and j is less than or equals to high. Right. What are you doing? If array of I is less than or equal to array of j, temp of k plus plus is equals to array of I. Is that the one? Wow. Wow. Or else temp of k plus plus is equals to array of j plus plus. That is it. So one of the two subarrays is completed. Is that it? Wow. When you understand it, things automatically get kicked in. That is it. That is it. Really. And merge sort. So for merging, you need this, and you've got to understand the main sound logic. Oh yeah, you didn't copy back to the array. Okay, it's almost 10 hours since I started the stream. After completion of the med sort, will take a break. Yep, I need a 15-minute break, and after that, I'll come back. And then, wow, we completed phase one after all of this brain burning. But it really paid off. See, every time it puts the Beatrice at the end. Because that is out of Beatrice is. It's like Beatrice are the final boss. ADS. Not ADS, but our syllabus. Multiple initialization. And updation of for loop comes in handy. They are not idiots, mate. So let's do like is that the condition? I less than or equals to I. Can't you do k less than I? is equals to. Oh, so you are saying in this code dot Oh, it actually understood. Okay, okay. Got it. I might point to a different index. Now it kind of clicked and it made sense. I will take a break for 10 to 15 minutes and I will come back. The head is really hot.